Hey students, this is lesson 514. In this lesson, we're going to learn how to find angle measures using algebra. So we're going to learn how to represent missing angle measures using algebra. To do that, remember just a couple things about the last two lessons, some things we learned about the relationships between angles and triangles and when two parallel lines are cut by a transversal. Just a couple things here, like let's say I label this A and this B. I know that A is equal to B because those are both alternate exterior angles. Let's say that this is labeled C. I also know that A plus C is equal to 180 because those are supplementary angles. Things like that. And in a triangle, let's say I label this A and this B, and it looks like it's a right triangle. I know that A plus B is equal to 90 because all three angles add up to 180. So if I took the right angle away from 180, I'm left with 90. So those are some of the ideas we're going to use. We're going to use variables to represent expressions. Notice that you can have more than one expression represent the same thing. If you use the variable h, so here's an expression, 35 minus 7, and that's the same as 4 times 7, both equal 28. If we use h to represent 7, then the phrases can be written in terms of h, so instead of 35 minus 7, we're going to put 35 minus h and 4 times h. All right, so that's just an idea of how we're going to use. So Jamie drew a triangle with angle measures 50, 25, and 105. So that might look something like this, where this is 50, this is 25, and this is 105. It says let the variable d represent a 25-degree angle. So let's just erase that 25-degree angle and put the letter d in there. All right. Now write an expression in terms of d to represent each of the other angles. So in terms of d, what would the other angles be? Well, notice that this one is twice as big as, notice that 50 is twice 25. So if we call this d, one way we could do it is call 50 2d. So the 50-degree angle could be 2d, right? 2 times d is equal to 50. We could also use addition to show that. We could say d plus 25. Or we could also say d plus d. Okay. And for the 105-degree angle, we could call that something like, maybe since 105 is 80 more than 25, we could call it d. 105-degree angle could be d plus 80, because d is 25. So those are just some examples. An expression doesn't have an equal sign, so there's our 50-degree angle, d plus 80. So here's our three angles. So remember, this is 25, this is 50 because it's 2 times 25, and this is 105. And then we could just write an equation by adding all three of those up, 2d plus d plus 80. So I added the three angles up, has to equal 180. And we could solve that. And if I did, remember to simplify these are all like terms, all these d's. So that makes 4d plus 80 equals 180. Subtract 80 from both sides and we get 4d equals 100. Divide by 4 and we get d equals 25. And of course we should have got 25 because we wrote all the angles using 25 as our starting point. All right, so that's kind of the idea of what we're going to do here. Let's look at this problem here and use our idea of something we know about circles. We know that there's 360 degrees in a circle. And we have two angles here. We have a smaller angle and a larger angle. And we're given an expression for each of those angles. Well, just given those two expressions, we know that this smaller angle plus this bigger angle have to add up to 360. So blank plus blank equals 360. And we can just substitute the expressions we get for the smaller one, 4x minus 35. Let's write that down here so we have a little more room. 4x minus 35 plus this angle, 4x plus 35 equals 360. And now we have an expression. We can simplify that, combining like terms. We get 8x minus 35 plus 35 is 0. So we just get 8x equals 360. And to solve that, we just have to take 360 divided by 8. And that equals 45. So x is 45. So now we can find the measure of each angle. This angle is 4 times 45 minus 35. 4 times 45 is 180 minus 35 is 145. And the other angle is 4 times x plus 35, so 4 times 45 plus 35, that's 180 plus 35 is 215. And so we now have the two angle measure, 145 degrees and 2 degrees. And those two should add up to 360, which they do. All right, let's try another one here. It says Matt drew a parallelogram that was not rectangular. He labeled the acute angles A and the obtuse angles B. So let's go ahead and draw a parallelogram. And maybe something like that. He measured the angles and found, so the acute angles he called A, so that would be this one and this one. And the obtuse angles are B, this one, this one. And he measured the angles and found that the measure of B was twice the measure of A. So just thinking about that, I can switch right now. Instead of calling this B, I can call it 2A. All right, and instead of calling this B, I can call it 2A. Now the reason I want to do that is so that I can just work with one variable. All right, now notice here that this line can be thought of as a transversal cutting two parallel lines. So we know from our earlier work that this angle plus this angle have to equal, they're supplementary, they have to equal 180 degrees. That's a 2A. So we can do 2A plus A to equal 180. And 2A plus 1A, those are like terms, so we can combine those. We get 3A plus 180. So 3 times A is 180, so A must be 180 divided by 3, which is 60. So A is 60 degrees. And this angle here is twice as big, so that has to be 2 times 60, which is 120. And these are the same, these A's are the same, and these two angles here would be the same also. So we found those angles using expressions to represent equations. All right, that's the kind of thing we're going to do. If you want to just practice a little bit more of that, go ahead and see if you can write an equation to find the sum of the angles in each of these. Thinking about what you know about the angles when two lines are cut by a transversal and how many degrees there are in triangles and things like that. All right, we'll talk about that the next time we meet in class.